video? Which video is this?
99.
99 confidence intervals for difference of means. Cool.
We are partying like it's 1999.
Yes. Now, Mr. Lewis has surprised me with a couple of problems here, so this is a total shock what we have today.
Well, I think you can handle it.
All right. I hope so. I got my 84.
Well, that always helps.
All right.
All right,
You can
so
do everything with this.
almost. Too bad it doesn't order pizzas or something.
Yeah, I'm waiting for them to build in the internet connectivity with this.
All right, so I surveyed 50 people from a poor area of town and 70 people from an affluent area of town about their feelings towards minorities. This could be a hardcore problem. All right, I counted the number of negative comments made. I was interested in comparing their attitudes. The average number of negative comments in a poor area was 14, and an affluent area was 12. The standard deviations were 5 and 4, respectively. So let's determine the 95% confidence for the difference of mean negative comments.
I want to go talk to these people.
I know.
This is a provocative problem.
Isn't it?
This problem makes me mad.
Well, guess what?
I'm going to find those 14 and 12 people.
Yeah, who doesn't like minorities?
I can't live in the middle of the. I don't live.
All right,
in the middle
so-
of the neighborhood. All right.
State the test and the conditions. So we want to do a 2-sample T confidence interval.
Oh, let's skip the test. Let's do
Okay. So
use a
this one.
confidence interval. How about that?
All right, so
We'll keep
just
this short.
CI.
So see the
Okay.
last video.
Okay, on the conditions and stuff. Hey, look at that.
No. It says state the test.
Oh, I know.
Oh, we're not testing.
I know, but it doesn't.
All right.
We
So
can
let's get
ignore
on
it.
with it. So we're
CI.
doing a 2-sample T test.
Right.
I get what you're going on now.
Yeah.
Okay. 2-sample T interval. I'm sorry.
Right. T interval.
That's a rough day.
I can tell.
But all right, we gotta go after these people making these comments.
All right.
Conditions.
All right.
First
well,
one, random samples.
random sample. Does it say? No.
And since you did the survey,
It's-
apparently,
Yeah. So
I
we're
would
gonna
trust you.
we're gonna say it's representative.
yeah. So we assume it's random or hope it's representative. So it didn't say.
Okay.
Next, is it less than 10% of the population
I would assume
in
so.
both cases?
Yes.
Yes. Almost always true with means. Okay.
Yeah.
Third, was it nearly normal?
Nearly normal. Again, it doesn't say. So we're just gonna have to assume that yes, it was.
Mr. Lewis.
What?
This is a difference of means, bro.
Yes, it is. The average number.
Oh, average number. All right. I was just like, okay.
We're now selling secrets in the middle of
This
videos.
is thinking, wait a minute, isn't this proportion? All right.
With a standard deviation. No,
We're good.
It's a mean.
It's Friday. I don't know what it is when you're watching, but for us, it's Friday.
Okay, we're gonna. Well,
We're back. Nearly normal.
yeah,
We gotta assume it. It's,
we're gonna assume normal. It doesn't say, and we can't really test it.
yeah.
So-
But we have to know that that's an important condition, and so
Yes.
whether it's there or not, we're gonna comment on it. All right. 4 is are they independent groups?
Yes.
Okay. So these are independent samples. We're assuming.
Okay.
All right. That was tough. Now
Yes.
we got 10 of these to go.
10 of these to go.
Yeah.
No. Conditions?
No.
No. Just
Problems.
One. Oh no, just one.
Just one. All right.
Okay.
I feel better. Now, let's state the formula. Is that okay?
Yeah.
All right. Y1 bar
So y bar 1 minus y bar 2
plus or
plus
minus
or minus the
T
t
star,
star.
and
Okay.
then times square root. So this is the formula for the standard error.
S1 squared divided by n1
Yeah.
plus s2 squared divided by n2.
Okay. So this, you gotta remember, for difference of means, degrees of freedom is hard. So hard to find out. So remember, we're kind of faking showing our work. So
Yes.
what we're gonna do is put in the values for here into the formula, show that we know the formula.
Mhm.
We have to wait to do the T star, but we're really going to use our calculator to find the confidence interval and degrees of freedom.
Right.
So we're just plugging into the formula to show that we know the formula and the parts of it.
All right. So while I plug it in, Mr. Miller will get our degrees of freedom. So here we have the average number. It was 14 minus 12 plus or minus. I'm going to skip that for a second. And this was 5 squared over 50 plus 4 squared over 70.
14 and 5 for the first one,
Yes.
and for the second one,
And then it was
12 and
12 and 4. Okay, that was n. N was 50.
That's why I thought it was never mind. All right, so x2 was
Then 12.
Thank you.
Then 4.
I'm not far from the nursing home.
Then 4.
Thank you, Mr. Lois.
Then 70.
That's funny.
Gonna be tying your shoes next.
See, this is why I gotta look at the problem ahead of time. What confidence?
95.
All right. I'm trying to wear slip-on shoes now. Thank you. All right, degrees of freedom. Whoa, 90.6.
90.6.
Now, this is screwy, but to show, we gotta go back and figure out what T star was. So we look at the T table.
Yes.
This was 95.6.
So 95. Now 90.6 is not, or 91 is not going to be on your T table. So you're just going to have to go with the closest number, which is probably going to be 100.
Well, you go up though. I told my kids you go up.
Yeah. So
Again, all right, this is 95%. So we're gonna go to 75. 1 point.
no, if we're going up, I thought we were going to 100.
No, I mean you go up in the table
Oh, okay.
because the smaller number is more conservative.
Got it.
All right, so
I
1.992.
misread you going
Yeah.
up.
I'm sorry, up in the table.
1.992.
Yeah, so you go for the lower value of degrees of freedom.
Okay.
And so we kind of fill that in. So that's kind of showing our work, and that should give us our interval, which we already have in our calculator. So the interval was from 0.30
0.30 to
3.6.
3.6.
69. All right,
Too bad I wrote 6.
so this is for the difference. All right, so
Right. So we are then 95% confident that the true difference between the two groups lies between 0.3 and 3.6.
yeah, so we kind of I had a rough time with this. So just to make sure we're clear, first is a confidence interval. So we state what kind, 2-sample T interval. We check the 4 conditions for difference of means.
Yes.
Then we wrote the formula. We plugged in the values. One value is hard, the T star. We kind of have to work backwards. So doing it in a calculator, we got degrees of freedom. We looked up the T star. Reason why is the degrees of freedom formula, the best formula, is really complicated.
Yeah.
Normally you're going to use a computer or software anyway.
Right.
We're doing this by hand normally to begin with. But they just wanted to make sure you know the formula and the concepts. So then we get our interval, and then we interpret our interval. And then we go on
Yes, we do.
to whatever's next.
Which would be your journal assignment. So, big long problem here. But you follow the same idea. So a research team is interested in the difference between a serum acid level in patients with and without Down syndrome. So we're science-based now. In a
I thought
large,
you were making this up until then. You couldn't have made this up.
in a large hospital of the treatment of mentally retarded, a sample of 12 individuals with Down syndrome yielded a mean of 4.5 milligrams per 100 milliliters. In the general hospital, a sample of 15 normal individuals of the same age and sex were found to have a mean value of 3.4. So if it is reasonable to assume that two populations' values are normally distributed with variances equal to 1 and 1.5, find the 95% confidence interval of the difference.
Piece of cake.
Yeah. I think they can do it no problem.
Okay, so state the interval.
Yeah. So here we'll.
That's okay. And then
That's what happens when
any
you're
conditions?
writing it fast.
now, the good news is every problem. What we notice in class is every problem like this is kind of like the same.
Yeah, they're not going to throw any real trick at you.
Yeah. So just fill in the formula, check the conditions,
And then calculate it out.
state your conclusion.
Mm-hmm.
Yada yada yada.
All right.
That's it.
Yep.